The next thing I would like to discuss are coterminal angles. Now you have to be careful that you don't confuse reference angles and coterminal angles. Reference angles are unique. In other words, for each angle there is exactly one unique reference angle. Coterminal angles are not unique. In other words, given an original angle, you can give me infinite amount of coterminal angles. Okay, the definition of coterminal angles is that they are angles that have different amounts of rotation but the same terminal side. Let's do an example to figure out what we mean by coterminal angle. So first of all, we want to find an angle that's coterminal to theta equals 575. What we will do is we will think about 575 being greater than 360 degrees but less than 720 degrees, which would be 2 full rotations. So what we'll do is we'll take to find a coterminal angle, and we will use the 575 degrees first, and we will subtract off 360 degrees. Okay, if we do that, we take 575 and we subtract off 360 degrees. That gives us 215 degrees. 215 degrees is the angle coterminal to the one that we originally were given. Okay, a picture of what this looks like as far as your drawing, 215 degrees would be located off in here somewhere. Okay, that would be my coterminal angle. 575 degrees, to achieve that, you would need to rotate 360 degrees around and then an additional 215 degrees. And so that would have been my original. So you see that these two angles are in the same location, they just have different amounts of rotation. Now, a big deal about this is that trig function values are equal at the original angle in any angle that's coterminal. You don't have to specify the quadrant that your coterminal angle falls within, because when you say that 575 and 215 degrees are coterminal angles, then you know automatically for both of those that they are in quadrant 3. So you don't need to specify the quadrant that a coterminal angle falls. So for example, let's say we want to find the tangent of 450 degrees by using a coterminal angle. First of all, let's draw this. Okay, so 450 degrees, I need to figure out where that's located, which quadrant that it's in, or if it's not in a quadrant, which axis it falls on. So first thing I'm going to do is I'm going to find a reference angle. Okay, 450 degrees is larger than 360 degrees, so I'm going to subtract those two values off. When I do that, I actually end up with 90 degrees. And so what I'm going to do, I'm not even going to graph 450 degrees, however, I am going to graph 90 degrees. So here's 90 degrees. That is my coterminal angle. And so to find the tangent of 450 degrees is the same thing as finding the tangent of 90 degrees. Because I'm on an axis, I know that I assume my r value is 1. I'm on the positive y-axis, and so my x will be 0 and my y will be 1. The tangent of 450 degrees is equivalent to the tangent of 90 degrees. Notice I don't have to specify where those two angles are. Their terminal sides are located in exactly the same place. Tangent being the ratio of y over x. In this case, we see our y value being 1, our x value being 0, and so this answer would be undefined. Okay, let's look at another example. Okay, let's say we want to find the cosecant of 585 degrees by using coterminal angles. So the first thing I want to do is I want to find an angle that's coterminal to 585 degrees. Now let's say that that's a huge angle. Let's say, 1,585 degrees. What you do is you keep subtracting off increments of 360 degrees until you get something that is either on an axis or something less than 360 degrees, so you can see where that angle is going to be located. So theta, that's coterminal, I would find this by taking 585 degrees, subtracting off, first of all, 360 degrees. If I do that, I get 225 degrees. Okay, that's less than 360, so I can draw that, and I know an accurate place to locate that angle. Okay, that angle is going to be located in quadrant 3. There's 225 degrees. Okay, you see on this particular one, I actually now need to go and I need to use a reference angle to create a triangle in that location. So what I'll do now is I will do a reference angle. The reference angle is measured from the terminal side up to the closest x-axis in this case. If I do that, my reference angle is going to be found by taking 225 degrees and subtracting off 180 degrees. If I do that, I get 45 degrees. This one I have to specify the location. It's in quadrant 3. Okay. On here, since I know that this reference angle is going to be 45 degrees, I can go ahead and label the sides of this triangle. I know that the r value would be the square root of 2, the y value is going to be -1, the x value is going to be -1. Okay, so cosecant of 585 degrees is equal to the cosecant of 225 degrees, which is equal to the cosecant of 45 degrees. Here I have to make sure to specify that this is in quadrant 3. Okay, now you actually don't have to write this string of equalities. As long as you give me the value here, I'm alright. Okay, cosecant is the value r over y. The r value was the square root of 2. The y value was -1. And so this reduced answer would be negative square root of 2. This concludes the lesson on finding trig function values using coterminal angles.